Hey everyone, welcome to my channel. In this video, we will create an advanced gesture volume controller using computer vision. This is the second part of the gesture volume control project. Here we are going to make the system smoother and use the pinky finger to set the final volume. We will also add some filtrations to make it more stable and usable in the real-world application. If you would like to create real-world computer vision apps, do check out my premium course in which we learn how to create apps such as object detection, augmented reality, document scanner, and a lot more. The link is in the description below. So without further ado, let's get started. So we are here in our PyCharm project, and this is the same project that we used in the hand tracking project, in the virtual painter, in the finger counter. So we have done quite a bit of projects earlier, and this is the same project that we did our volume hand control as well. So we have the files here. So we don't need the rest of them, but we will need the volume hand control and the hand tracking module. So if we open hand volume control, you will see that this is our code that we did last time. This time around, we are going to make some changes. We are going to add a few more things to make it a little bit better, a little bit smoother, and a little bit more usable. So that is our main idea. So what we are going to do, we have everything set up. And if you are viewing this video for the first time, you have to actually install MediaPipe and OpenCV Python. So you can go and install from here. You can write OpenCV Python, and then you can write, and then you have to hit install, and then you have to write MediaPipe, and then you will hit install. So these are the two libraries that we need. And the third thing is your hand tracking module that will be required in the same folder. So that is the main idea. Now, I highly recommend that you go and check out the first video before actually watching this. So volume hand control, make sure you check that video out, because if you don't view that video before this, it will be a little bit confusing what we are doing. Okay, so now let's divide our work first into some categories, and then we are going to write the code for each one of these. So first of all, we are going to find our hand. So we will write here find hand, and then what we will do is we will filter it based on size. So here we will go down and we will write here filter based on size. Now this is because when we go back, when we are really far away, when we are measuring the distance between the index finger and the thumb, it will give you very small values. So they will not be usable. Now, the other thing that I thought about this was normalizing these values. So normalizing the complete hand. So that means that, for example, if the size of my hand is, let's say 400, I will resize it to 500. And every time, it doesn't matter what the size of the hand is, I will always resize it to 500. And then based on that, I will check the distance between my finger and thumb. Now, the thing is that the size actually keeps changing. So the width and the height, they keep changing. I even tried with a little bit of ratios, but the results were not very smooth. It does work. So no matter if you're far away or you're close, it will detect the same size, and the values will be very much similar if you are very close or you are very far. But the issue was that it was not very stable. So I will not go ahead and do that. Instead, we are going to filter it only based on size. So if we have, let's say, the size of 300, then we do not use it. It should be, let's say, between 400 and 500. So these are just random values that I'm referring to. But later on, we will see actual values. How can we do that? But to do this, we need the bounding box of our hand. Now, we did not do this in hand tracking, and we did not do this in any of the other projects. So we will look at how we can get the bounding box of this as well. Because the MediaPipe library, as far as I know, they are not supplying this information by default. You have to add a little bit of code to actually find the bounding box of the hands. So we will do that too. Then after we do the filtration, then we are going to find distance between the index and thumb. So this we have already done, but the thing that we will change is that we are going to convert all of this into a method in our class, because we are doing a lot of different projects, and every now and then we will need distance between two fingers. It could be index or thumb, it could be pinky and index, it could be any different number of fingers. So what we will do is we will create a method so that we just input two values and it will find the distance between these two fingers. So that will be very easy to do. Okay, and then after that we are going to convert our volume, from the length to actual volume. Now here we are going to also make it smoother. So we will reduce resolution to make it smoother. So for example, instead of incrementing with 1, we can increment with 5, we can increment with 10. So for example, it will go from 0 to 5 to 10 to 15 to 20 and so on. So this way it will not change with a very small change in the distance. It will be much smoother and much more usable. Okay, then we are going to check which of the fingers are up. Check fingers up. Again, we are going to create a method for this. Now, if you haven't watched the virtual painter, the finger counter. So in the finger counter project, we had this, method of finding which fingers are up. And in the virtual painter, what we did was we created a method out of it in our class. So if we go to our hand tracking module, you will see that, no, this is the minimum. Where is the hand tracking? This one. Okay, so here you can see this is our method that will check which fingers are up, and it will just return us a list of numbers. So it will have 5 numbers and it will have 5 values, and each value represents whether the finger is up or not. So we are going to check that. But why are we checking this? Because we will set the volume only when we close our finger, the pinky finger. So our pinky finger will be the one that will set the volume. So we will change the volume with our index and thumb, but we will set the volume with pinky. Because setting the volume is very hard, because you will have to remove your hand instantly to keep the same volume. So it is very hard to do that, and there are other ways, but this is one of the easiest ways, and this is one of the fastest ways you can use. So we are going to check which fingers are up, and after that we are going to set, we will check if pinky is down, set volume. So that's the idea. And after that we will simply do all the drawings at the end. So we will write here drawings. So this is the main idea. So we will go step by step, and at the end we also have the frame rate. So we are going to look at that. So these are the steps that we are going to follow today, and we will go one by one and see how we can achieve this. Now the first thing we will do is to find the hand. So we have already done that. Now we have to filter based on size. Now filtration based on size is based on the bounding box, but we don't have the information of the bounding box. So what can we do? The idea is that we will go to our hand tracking module and we will go to find position. Here we are getting all the different points of our hand. So what we need to do is we need to find the maximum X and the minimum X and the maximum Y and the minimum Y of any of the points. So what we will do is we will put all of these in a list, and then we will check the maximum value and the minimum value of that list. Okay, let me explain it a little bit further by just starting to code. we will write here X list. So this is the list that will contain all the values of X, and this is the list that will contain all the values of Y. Now we could do this with NumPy as well with a little bit more efficient code, but we are going to do with simple lists because it is easy and straightforward. So we will put all the values. So here, whenever we have an X and Y value, we will write X list dot append, and we will write X CX, and then we will write Y list append. We are going to write CY. So this is the idea. We are appending all the values, and once the for loop is done, we will go down here. Once the for loop is done, we are going to check the minimum and maximum values. So here we will write X minimum and X maximum is equals to minimum of the X list and the max of the X list. Then the same thing we will do with our Y, and we will just make it Y, 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 and Y. There you go. So now this is giving us the X minimum, X maximum, Y minimum, and Y maximum. So this is basically our bounding box. So we can write here bounding box is equals to X minimum, then Y minimum, and then X max, and then Y max. So, and now we can also return the bounding box information. So this is basically the idea. So now if we go back to our volume control, actually, you know what? Let's keep it like this. I will copy all of this and I will paste it into a new one, a new file, and we will call it volume hand control advance. Okay. Oh, did I put a space in between? That's bad. Okay, so now we will paste it here and we will do it with this rather than the volume control. Okay, so here we are going to write lm list, and we are returning the bounding box information as well. So bounding box, we will write it like this, and then inside here we are going to print the value of the bounding box. So we'll print here bounding box value. So let's try this out. Let's run the volume hand advanced. Okay, so we are getting an error because we are not referencing it before. Wait, what? Is it? Okay, it's here. Oh, the problem is here because, wait, there is a problem here as well. Append. Other than that, the problem is that we are sending it back, but we are not declaring it. So we need to write here bounding box is empty. So let's run it again. There you go. So now if I bring in my hand, you will see we are getting the bounding box information. This is the bounding box information. So let's draw it. So we will do here that, or we can put this functionality here. We can write that if draw, because we already have a draw flag and we are using it where here we are using it already, so we can use it again. If draw, so we will write here cv2.rectangle, and then we will send in our image, we will write our bounding box, and then we will write the color. So it will be 0, 255 and 0, let's say, and then the thickness is 2. So let's run this and see if it draws around our hand. Nothing. Why didn't it draw? So it is checking. Draw is true or false? Oh, it's false here. That's why it's not drawing. So let's make it true. There you go. So now you can see it is getting the bound. Something is wrong here. What? Something is very, very wrong. I think the bounding box, it expects width and height. And here we are giving the actual values. So maybe that's the issue. So instead of doing this, let's write 0 and let's write 1, and then let's write all of this again. This will be 2 and this will be 3. So let's try that. Yeah, so that was the issue. So here you can see we are getting our bounding box now, and it is drawing these huge circles which look very weird. We can reduce the value of these circles, let's say 5. There you go. So now we are getting our bounding box, but you can see it is at the exact point. So if you see my pinky finger, it is at the exact same point. So that might be a little bit inconvenient. So what we can do is we can add some values here. So we can say -20 and -20, and here we can say +20 and +20. So we can try that again. And now you can see there is a distance. So it's not exactly at the same point. So it looks a little bit better. So this is how we can get our bounding box, and you can see it's quite fast and it's good. Okay, so what we will need next is the actual value. Let's just remove the print that we have earlier, and we will go back here. And now what we will do is we will take the last two values and we will multiply them. Or no, we need the width and the height. So we need to subtract them and then we can multiply. So what we will do is we will say that our bounding box, so we basically need the area. We can go up here and we can declare here area is equals to 0, let's say. And over here, we are going to say that our width of our, let's say, box and our height of our box is equals to bounding box at, first of all, we will take the second value for the width. So it will be 0, 1, and 2. So 2 minus bounding box at 0. And then the same thing, bounding box at 3 minus bounding box at 1. So this will give us the width and the height. Should we just let's just multiply it here. Area is equals to this, and we just multiply it here, making sure that it is first calculated here and then multiplied. Okay, so that will give us the area, and we can simply print this area to see what kind of values do we get. So there you go. So now we are getting around, if I make it smaller, it's 20,000 something, 50, 31. Okay, let's go ahead and let's divide it by 100, or let's double divide so that it is a whole number. So there you go. So now you have 500, 400. If I come closer, so now we can decide when do we want to use these functions. So here, maybe this is way too far. Maybe this around 500 to 1000 maybe. So these are the values that we should use. If it is before that, we should not use. So this is what we can do. Here we can write that if the area is basically in between 500 and 1000, then we will do the rest of the things. So everything here we will do, except for the drawing, we can draw, except for the drawing, we will do everything if the area is in between here. So what we can do is we can write here print yes, and we will print yes whenever it is in that range. We are doing this just to check. So there we go. So if we are far away, it will not say anything. If we are close, then it says yes. And if we are too close, it will say no. Yeah. So this is a good range. But here you can see we might need to reduce the value a little bit. So let's say 350. Because this is the issue. When you are changing this, when you're moving your fingers, the size changes. Yeah. So we will have to make it even smaller maybe. So yeah, here it's fine. Let's make it 250. Yeah. So if it's really far, it will not work. If it's close, like this, it's too close, it will not work. If it's here, then it will work. So this is the perfect spot that we want to use. So I think that is pretty good. So this is our first part where we do the filtration based on size. Now we have to find the distance between the index and the thumb. So we did this earlier using this method, but what we can do is we can create this into a method within our class. So we have this class where we have find hands, we have the method find position and fingers up. And now we are going to create a method called find distance. So we will write here def find distance, and we are going to give in the point number 1, then point number 2, then the image, and then we have the draw is equals to true. So these are the this is the flag. So then the idea here is that we are going to get the values internally. We are not going to send it out and then get back in. This is just an ID. So it will be, for example, ID number 10, ID number 8, ID number 4. So we don't have to get the actual points, the actual X and Y position. So how can we do this? We will go to our volume control and we are going to cut all of this. And we are going to go back to hand tracking and we will paste it here. And here we are going to say that our self.lmlist is basically this. And then we will just replace the self again and again. So this is the basic idea and the rest should work fine. There's no math because we didn't import it. So we will write here import math. And we can go down again and the rest is fine. So here this is all for drawing, so we can write here if draw. So if we want to draw, then we do all of this. So that is the basic idea. Do we need to draw something else? No. Okay, so what we can do is now we can return these values. So we can say here that return length and return the image on which we have drawn. And then we can also return X and Y. So we can return all these values X1, Y1, and then X2. In case we want to use them, it's not compulsory, but in case we want to use them, we can write these X, then Y2, and then CX, and then CY. So we can return all these values. And here in the volume hand control, we can go here and here it says find distance between index and thumb. So we can write here that our detector dot find distance, and we want to find the distance between which index. So actually we didn't define here. So here instead of 4, it should be P1, and here also P1, and here it should be P2, and here it should be P2 as well. So yeah, so then it was 4 and 8. So here we are going to write 4 and 8, and then we will write our image. And we are getting back a lot of different things. So we are going to receive all of these and we will write length, GTH length, and then we are receiving the image then we are receiving the info. So we can simply write that this is info. Should we write what kind of info we are getting? Let's say line info. Line info. So that is good. Now let's try to print the length and see if we get it. So let's remove that. So yeah, we are getting the length and we got an error as well. So CX is not defined. Where is it not defined? Here. Okay, because we are not, earlier we had the CX and CY here. Now it is in line info. So CX and CY is basically over here. It's the 0, 1, 2, 3, 4th and 5th element. So we will get the 4th and 5th element. And instead of CX and CY, we will write here line info at 4 and line info at 5. So you can see it's already useful that we got the line info as well. So now you will see there is no error. So that is quite good. Okay, then the next step, now that we have the length, we have to convert the volume. And this we did earlier over here. So we are going to take all of this and we will cut it and we will go up and we will paste it here. Convert volume. Let's separate this a little bit so we can see. Now the thing is that we don't need to use the minimum and maximum volume because we know that it is a percentage now. We are going to use the linear scale rather than the logarithmic scale. So in the previous video we just applied a linear scale onto the logarithmic scale and it does not convert well. So in order to rectify that, we are going to remove this, and there is a function within this library that allows us to get linear values. So we can write here that volume dot set master volume level scalar. I know it's a long name, but that's the idea. So instead of writing this set master volume level, we will write set master volume level scalar. So that will allow us to send percentage values rather than just these converted values. So what we will do is we will send our volume percentage, and then again we will write none in front of that. So if we remove this now and we run this, you will see that let's open up the volume. You will see that, okay, there's an error. Master volume scale, the parameter is incorrect. Oh yeah, so you have to divide it by 100. So this value is normalized between 0 and 1, so you have to divide it by 100. Okay, so let's try that. So now you can see it is much smoother than before. So we can have 0, we can have, okay, we need to fix the 100 value because we changed all this. But now it is much smoother than before because we are able to easily move around, and we can check it on our volume as well. And now it is reflecting exactly the same as on the volume. Earlier, when we were reaching at the end, it will move, it will start moving, but now it is moving evenly everywhere. So that is the idea. So we can remove both of these. But the idea is we are not going to set our volume now. We will set our volume when we have the pinky finger up. So we can put it here. If pinky finger, actually when it's down, so we will set the volume. So we can put it here. Later on we will add some code. So the next step is to reduce the resolution. Now, why do we want to reduce the resolution? to make it smoother. So if you are changing each and every single volume value, so you are going from 58 to 59 to 60 to 61, then it's a little bit harder to set these values. So what we will do is, in Windows, I think the increment is of 2. Yeah, so you can see here the increment is of 2. So it goes from 40 to 42 to 46, 44, then 46, and so on. So what we can do is we can put a value of smoothness. We can call it smoothness is equals to, let's say, 10. And here we can write volume percentage is equals to smoothness multiplied by, we are going to round the value, and we will divide our volume percentage with smoothness. So that will give us what you call smooth values with increments of 10. If we want increments of 2 like Windows, we can write it 2. If we don't want any increment, just increment of 1, we can write it like this. So let's try with 5 first. So now you can see it is much smoother. So you can see 40, 45, 55, 60, 65, and so on. There you go. So we can try it with 10. Now it is way smoother. It's very satisfying as well. Okay, so I think we will keep it on this. Let's keep it at 10. Then we are going to check which fingers are up. So we have already created this function over here, fingers up. And as I mentioned before, this was available in the finger counter. We first wrote the code in finger counter, and then we created this method in the virtual painter project. So it is very simple. You don't have to go and see the whole video to understand this. The idea here is that we have a list of fingers, and it will contain 5 values. Each value can be 0 or 1. So if it is 1, it means it is up. If it's 0, it means it is down. Then what we do is we check if the point that is above the finger, let's talk about the finger first. If the point that is above the finger, let's say the tip point, it goes below the point that is 2 values before it. If it does that, it means it is down. Then we write, this one is for up, by the way. So we are checking the opposite thing. If it is up, and then if it is not, then we will put 0. So this is the idea, and here it is left and right. So if you want to go into the details of this, do check out the finger counter project. So I have explained this in detail over there. Then it will return this finger list. So what we can do is, to understand this a little bit further, we can write here fingers is equals to detector dot fingers up, and we will print fingers. So let's remove the length and let's print that. So here you can see, okay, the thumb is wrong, but yeah, I remember, didn't change that. If we go to fingers here and we reverse this, it should work with the thumb as well. Again, we are not using the thumb really, so it doesn't matter in this case. So what we care about is the fingers, actually the pinky finger alone. So here you can see it goes to 0, here it is 1, 0 and 1. I can do with the rest of them, so all of them are 0, 1, 2, 3, 4, and 5. So we can do that, and what we need is the pinky finger only. So whenever we put the pinky finger down, we will set the volume. So we will go here, and we are going to check. So here we are getting the fingers, and that is good for us. And that is good enough for us. And now we are going to go and check if the pinky finger is down. So here we will write if, we will write not fingers at 4. This is the last element. Not fingers just means that if fingers is equals to false. So you can also write it like this, is equals to false. It's the same thing. So if it is false, then we are going to set our master volume. So this is the idea. And what we can also do is, we can change the color. If you remember, whenever the length was less than 50, we were changing the color to green. Let me show you here. So if the length is less than 50, we change the color to green. Now, instead of doing this, we are going to change the color to green when we set the volume. So it is an indication that you have already set the volume. So we will remove this condition. So here, now if I put my pinky finger down, you can see it turns green. You can see that. And now it will set that volume. So here, if I check my volume, so right now if I change, it will not change. But right now it's 50, and if I put it down, it becomes 50. If I put it at 70 or 60, it becomes that. So if I go to 30 and do that, you can see it changes. So my hand is moving a little bit. So let's say I put it at 40, and I do, it goes to 40, 30, goes to 30, then 20, then 10. If I keep it down and then change, it will keep changing. The value will keep changing. Why is it flickering that much? Okay. So you can remove this flicker by going to the detector, and you will say that the max hands is equals to 1. So it will not try to find another hand. There you go. So now if we do that, and if we rotate, you can see the volume. Let me open the volume first. So the volume will keep changing if my pinky finger is down. But as soon as I put it up, it will set the volume. So this is the idea. So we go down and we set. We go up and we set. So that is the basic idea. So that works well. You need a little bit of practice to actually get used to of it, but it seems quite good. Now what we can do next is we can change the color and we can add some indications for the drawing. By the way, the frame rate we have already done, so we can put the frame rate over here. So we can remove it from here and we can write it here that this is for the frame rate. Or is it? No, this is for the frame rate. This part is for the frame rate, and we can remove all of this, and this part here is for the drawings. So drawings is up to us. If we want to do it when we detect the hand, we can push it in and it will only do when the hand is there, or we can always do it whether the hand is there or not if we take it out of the if statement. So we can keep it outside for now. And what we can do is we can change this a little bit. First of all, we are going to add, let's say, another one of these. So we will set our master volume. So whenever we set the volume, we are going to display, or we can display it always. So for example, we want to check what is our volume. So rather than going and checking on the windows, we can write here that our current volume is equals to volume dot get master volume level and scalar. So this will give us the value. We will multiply it by 100 and we will make it an integer. Or should we round it? Let's round it. No, round will not work properly. Let's just do the integer. Okay, so we will write here current volume, and then we will write here current volume, and we can write here volume set. So this is the volume that has been set. So we can write that, and we can change the location of this to, let's say, 450. Let's try that. Yeah, that looks good. So right now the volume is 69, and if we go here and we do this, it changes to 40. If we do this, it changes to 30. Go up, it changes to 40. We go to 60, it changes to 60, and you can see. One more thing we can do is we can change the color of this as well whenever it is set. So it gives a better indication that the volume is set. So to do this, we will go up here and we will write here. We will write here that our volume, let's say color volume is equals to, initially it is blue, so we will write blue, and then whenever it is detected or whenever it is set, we are going to change it to green. So this is the case where it is set, so we are going to put here and we are going to write 255 and we will write here 0. And instead of using a fixed color over here, we are going to use color volume. So let's try this. So right now it's blue. I bring in my hand, and if I set it, you see it becomes green, but then it doesn't go back. So we need to write an else statement here. We will write else, and we will write color volume is equals to 255 0 and 0. So it will become blue again. So there you go. So if I do this, you can see it sets the volume and it goes back. So that is pretty good. Now, if you want, you can add a delay here. You can write, for example, time dot sleep, so that it doesn't move around a lot. I don't like this, but you can, if you want to add it, you can add it too. So if I do this, it will delay a little bit and it will set it a little bit better. So while we are setting it, we will not move a lot. So that's the idea, but I don't like to put this here. So this is basically the idea. Do we need to change anything else? So here is check fingers, if pinky up, it fits down, drawings, and that is, I think we are pretty much done. So again, you can play with the resolution, you can play with the volume, and you can play with these displays. So you can change their colors, you can change their size, and when the volume is set and whatnot. So this is quite good. Let's try it again. So here my volume is 20 at this point. If I do this, it becomes 50. Actually, let me open up the actual volume as well, so you can see it's actually changing. So here it is, let's say 70 or 80, then we do this, it becomes 80. Here it is 30 or 40, we change it to 40. Then this is 60, changes to 60, 30, changes to 30. There you go. So it takes a little bit of practice, but you can do it. And now we can also see that it doesn't go to the max. So this you can change, this thing you can change by changing the size. So here we can change, instead of 300 we can put, let's say 280 if we are facing some issues. So let's try that. Okay, it's still an issue, so let's make it 250. So let's try 250. Yeah, it goes, but it's still a little bit hard, especially if you're at the back. Let's make it 200 so it is easier all the way around. Yeah, so even if you are at the back or at the front, you can go till 100. So again, you can change this based on your area as well. So now you have that flexibility. So here you can see we are setting different volumes. So that is the main idea. So sometimes it gives one value less because it is rounding off. So this basically means 90. So if we check here, it will be 90. Yeah. So this is basically today's project. I hope you have learned something new here. It is quite satisfying to actually produce something that could be useful. So if you like this video, give it a thumbs up and share it with your friends. And don't forget to comment if you don't understand anything. And there's also a Discord channel that you can go, and if you have any questions, you can put there as well. And somebody will definitely help you out there if I'm not able to answer. So this is it for today's video, and I will see you in the next one.